So this is a question of JEE Mains 2019. It says that there are two blocks A and B of masses MA equals 1 kg and MB equals 3 kg that are kept on a table as shown in the figure. The coefficient of friction between A and B is 0.2 and between B and the surface of the table is also 0.2. The maximum force F that can be applied on B horizontally so that the block A does not slide over block B is. So basically we are given with two blocks. The first block is A and is kept on another block B, and the coefficient of friction between these two blocks is also given to be 0.2. The mass of block A is given to be 1 kg and the mass of block B is given to be 3 kgs. And we have to find the maximum force that we can apply in this direction such that A remains in contact with B, or in other words that both A and B keep moving with the same acceleration and A does not slide over B. That means both A and B remain in contact and they continue moving with the same acceleration. And what should be the force that should be applied in this direction so that this condition prevails? Now, if we talk about the free body diagrams of both of these blocks, B as well as A. So for B, we're going to apply a certain force in this direction to cause a certain acceleration, and opposite to this motion there's going to be a force that's going to come into play to oppose this motion, and that's going to be the force of friction. But if we talk about block A on the other hand has a tendency to stay where it is because of its inertia, so it has a tendency to stay back, but it keeps moving on forward along with B. So the force of friction, which is acting in the opposite direction of its tendency of motion, this is what causes this block A to accelerate in the same direction as that of B. Since A has a tendency to remain where it is, its tendency of motion is generally in the backward direction. However, friction is something that opposes this tendency of motion and causes it to move along with B. So the accelerating force for block A is the force of friction itself. Now, we know that the force of friction is going to be equal to mass into acceleration, right? So a force of friction is given by mu mg. So mu mg is going to be mass into acceleration. We know what mu is. Coefficient of friction is given as 0.2. Mass is 1 kg for this block A, because this Fr, frictional force, is going to cause the acceleration of this block. So mu is 0.2, mass is 1 kg, g gravitation is 10, and mass again is 1 kg, and the acceleration is something that we have to find out. So the acceleration that we get from this entire setup is 2 meter per second square. That means block A is moving with a velocity of 2 meter per second square, and block B also has to move with the same acceleration, that is 2 meter per second square. So now that we have the acceleration, we know that for block B, for the second part of this question, we are going to take both block B as well as block A as the entire system, as one entire system. So the mass of this one block is going to be 4 kgs because the mass of A was 1 kg and the mass of B was 3 kgs, and the mass of the entire system becomes 4 kgs. So for this entire system, we're going to have a force acting on this direction, force of friction opposing the motion, and acceleration is going to be in the direction of the force, and we found that out, that is 2 meter per second square. Now, finding the net force. The net force is going to be the acceleration causing force. So force that we have applied as an external agent minus the force of friction, because this is going to be the larger one as the block is going to move in this direction. So this force minus the force of friction is going to give us mass into acceleration. Force applied is going to be mass into acceleration plus force of friction. Now the mass, we're considering both of these blocks as a single system because they have to move together as a single unit. So mass is going to be 4 into acceleration. We just found that out. That is 2 meter per second into force of friction. That is mu mg. 0.2, mass 4 kg, g 10. So it's going to be 8 plus 8 and it's going to be 16 newtons. So 16 newtons is the amount of force that is required to keep block A as well as block B in contact and moving with the same uniform acceleration of 2 meter per second square.